guys, welcome to another episode of MrLopezClasses.com. This is an episode of the chapter 12, the AC wiring. I am going to explain the procedure to do the wiring on the AC panel, and I am going to give to you some tips related with the procedure to do the wiring. In this particular example, I prepare in the board an example in order to wire a double phase boat. We are going to start the procedure from the shore power, and after that we are going to check a board that I prepare for use. Okay, this is basically the wiring diagram. This is the shore power. The shore power double phase receive the phase 1, phase 2, and neutral and ground coming from the transformer at the beginning of the dock. That power is coming in big cables. You remember in other episode, the episode related with pedestal. You can check that episode. This is the chapter 12. The second episode is related exclusive for pedestal. The procedure to check the pedestals and troubleshoot problems on pedestals. Okay, the power is coming from the transformer at the beginning of the dock. Normally the power is coming in cables and the gauge number 2, 100 amps in each phase. In this particular case, two phases are coming, the black one, the red one, and the blue one is the neutral. All of those cables will be number 2, and the ground, of course. In the bottom of the pedestals, those wires enter in the bus bars. One bus bar for neutral, other bus bar for hot number 1, and other bus bar for hot number 2. Hot number 1 is black, hot number 2 is red, the neutral is the blue one, and of course the ground is the green. In the pedestal, from each bus bar you fit the button of the breaker of the pedestal. Remember, in the pedestal you have one breaker per each outlet, one breaker dedicated per each hour. This breaker is for this outlet. This breaker receives one hot line, two hot lines, and neutral. Remember, the ground is out of the breaker. The ground never passes through the breaker. And in the output of the breaker you have hot line, and neutral. Okay, this is the shore power line. This is the output, this is the outlet of the pedestal, and the shore power line is connected here, and the other end of the shore power cord is connected with the outlet at the entrance of the boat. This is the shore power cord. Hot, neutral, and ground. Hot, neutral, and ground. In the majority of the boats, for safety, the boat have another breaker here inside of the boat. They have another breaker here. But in general, when I wire a boat, new wiring, I install another breaker here. It's not mandatory. Alright, you have the outlet here, and inside of the boat you have hot, neutral, and ground. The hot, neutral, and ground is going and entering into the switch selector. The switch selector for shore power, generator, or inverter. Right now we are going to check this switch selector on the board. Okay, you have one input from the shore power, and you have another input, hot, and neutral, coming from the inverter, and you have another input, hot, neutral, and ground, coming from the generator, and this is the common, this is the output. Once again, this is the AC switch selector. AC switch selector. You remember in DC, the red one? That's the DC switch selector. Battery bank number 1, battery bank number 2. This is similar, but this is for AC. Shore power, generator, and inverter. Those are the three sources of AC power. Okay, and this is the common, this is the output. The output in this particular case, because it's a double phase, is entering in the isolator transformer. The isolator transformer receives the output power coming from the switch selector, and in the output of the isolator transformer is the power entering into the main breaker of the AC panel. One important thing. This is the isolator transformer. What is the function of the isolator transformer? You remember in the chapter 10, the second episode, I explained isolator transformer and galvanic isolator. And I explained the function of both of them. If you remember, the function of the isolator transformer is clean the AC signal. Why? Because what happened with the signal here at the input of the transformer is a signal that is a little contaminated. Contaminated with what? With noise, with interference. Why? Probably because of background or interference with other equipment. What happened with the signal in the output of the isolator transformer is a clean signal. It's completely clean in comparison with the input. What is the function of the transformer? Clean the signal. All right. I put the transformer here. Other manufacturers, other technicians recommend the transformer here only to protect the power coming from the short power. In my opinion, this is not good, because what happens if the output power from the generator is contaminated? Yes, this is possible. If the generator is an old generator and the winding have too much humidity, dirt, that's possible. The signal will be contaminated. What happens if the ground of the generator is not good? The output signal is not clean. In this position, you clean the signal coming from the generator, or the signal coming from the short power, or the signal coming from the inverter, and the output always will be a clean, clear signal. For that reason, I recommend locate the isolator transformer in the output of the switch selector, the AC switch selector. Okay, the isolator transformer receives hot, hot, and neutral, and in the output hot, hot, and neutral, entering in the main breaker of the AC panel. The main breaker of the AC panel. Hot, hot, and neutral. And this is the output, hot, hot, and neutral. And of course, the neutral enter in the neutral bus bar. Alright, now we are going to do the wiring for that panel. That panel, because this is a double phase boat, have double phase breakers and single phase breakers. There are breakers double phase for air conditioning equipment, for water makers, for some appliance double phase. And there are single phase breakers for blowers, lights, computers, TVs. Those are single phase breakers. Okay, what is the advantage of this configuration? You have two phases. You can create one group of breakers for one phase, the red one, and you can organize other group of breakers for the second phase. And you can balance the load in order to keep both phases working with the same or similar load all the time. What happens if one phase is working with a double load in comparison with the phase number one? In what situation you know that the system is unbalanced? It's basically when the boat is working with generator. When the boat is working with generator and one phase is full, for example 80 amps, and the other phase is only 20 amps, you hear on the generator the rotor of the generator try to touch the stator. That's not good. For that reason, it's good idea per each phase install ammeter and voltmeter per each phase. If you are the engineer of the boat or the captain, periodically you go into the cabinet and you verify if the amps for both phases are similar. This is very important. Right now I am going to explain the procedure to wire that boat. Suppose that I am going to organize per each phase two double breakers and two single breakers. Two double breakers and two single breakers. Okay, one double breaker is for air condition, other double breaker is for water heater, other one for the dishwashers, other one for refrigerators, double phase equipment. And single phase for computers, for lights, for outlets, single phase outlets. Okay, remember, when I have a double phase breaker, it's because I am going to enter in the input of the breaker two different phases. Now I have a solution. I have only one phase. I split the cable in two. This is not two phase. This is the same phase. Be careful with that. For example, in this particular case, from the phase number one, the black one, enter in the hot bus bar for phase one, and I feed one input of this breaker, one input of this, the single breaker and the other single breaker. And from here I pass in front and I feed the second phase of the double breaker. And with the red one exactly the same. I feed this and this, and I pass in front and I feed the second phase of this double breaker. And right now those double breakers are ready to activate double phase equipment. Okay, from the single phase equipment I feed, for example, the computer. The phase is here, this is the neutral and the ground. Be careful with this. When I am going to feed a single phase equipment, I am going to use the hot line and the neutral. Of course, the ground is from the case of the equipment. Hot and neutral for single phase. I am going to feed a double phase equipment. The double phase use hot line, and ground, no neutral. Phase 1, phase 2, and ground, no neutral. The reference in double phase or three phase is hot, hot, ground, or if it's three phase, hot, 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 and ground, no neutral. The neutral is used exclusive for single phase. For that reason, the neutral bus bar only feed single phase breakers for single phase equipment. The double phase breakers are, the reference is with the ground, and the three phase is with ground. Hot, hot, and ground, or hot, 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 and ground. This is the procedure. Okay, right now we are going to install the ammeter and the voltmeter. Okay, the ammeter, the amps, we are going to use this equipment. We are going to use the donut. The donut, if you remember, is a magnet. Half is positive and the other half negative. Positive and negative. And I am going to pass the donut through the hotline cable. That's the hotline cable. Hotline 1 and hotline 2. I am going to use two donuts. One donut for phase 1 and other donut for phase 2. And the end of those cables from the donut goes directly into the ammeter. That's simple. That's the procedure to connect the ammeter. You use the donut, both terminals of the donut to the ammeter, and the donut through the cable. One donut for one phase and the other donut for the other phase. What about the voltmeter? The voltmeter is too simple. The voltmeter have two terminals. Exactly the same. The voltmeter have two terminals. This is the AC voltmeter. Two terminals. One for hot and the other one for neutral. Okay. One for the hot line bus bar and this one directly to the neutral bus bar. And the other voltmeter for the other phase to the hot line and to the neutral. Okay, I am going to connect the frequency. I want to connect the hertz per each phase. The frequency, the frequency hertz is normally connected in parallel with the voltmeter. Remember when you try to read frequency on AC power, you connect on the hot and neutral, and in the multimeter you read voltage and you switch immediately to hertz. Basically, the procedure to connect the voltmeter is in parallel with the voltmeter. Now the frequency is connected in parallel with the voltmeter. And right now on the panel we are going to check that connection, and we are going to read frequency with the multimeter. I can connect one frequency gauge for one phase and other frequency gauge for the other one. This is recommended. If you have about double phase, you need voltmeter, ammeter, and frequency meter for one phase, and the same for the other phase. If you have three phases, one per each phase. And additionally, if you have a double phase, I recommend other voltmeter in order to verify the double phase. 240 volts, 60 hertz if the boat is American power. And you connect one phase to the black bus bar and the other phase to the red bus bar. And that voltmeter is reading 240 volts voltmeter. You have one voltmeter for one phase other voltmeter for the other phase, and other voltmeter for the double phase. Okay, now I am going to explain the same procedure on the board, and I am going to show to you the procedure to do the wiring and the procedure to use the voltmeter. Okay guys, this is a board, AC board, that I prepared for use. In this particular example, the board is single phase, but it's exactly the same for two phase or three phase. Alright, this is the typical AC panel in a boat. I have the main AC panel, the main breaker, the single breakers, and the main breaker is receiving the power from the transformer. The transformer is in the back, and the transformer receives the power from the switch selector. This is the AC switch selector. Generator position, inverter position, or short power position. Short power, inverter, generator, and this is the output. This is the switch selector for one position, two positions, three positions, and off. Right? This is the switch selector, AC switch selector. Some people, some technicians, some captains, they prefer, instead of a switch selector with three positions, they prefer three individual breakers with a slide bar. They say, oh, I am going to use right now my boat in short power. I turn on this one on and the other ones off and off, inverter and generator. No, I want to work right now with the inverter. Okay, inverter on, off and off. No, I want to select right now generator. Okay, generator on, off and off. Yeah. Some people prefer the breakers independent, or the switch selector. This is too expensive in comparison with this. Okay, let me explain how is the wiring in the back of those three breakers when you use three breakers individuals instead of the switch selector. The procedure is this. This is the procedure. This is the short power. This is the pedestal, and the pedestal produce, in this particular example, double phase and neutral. Phase 1, phase 2, and neutral. And I have three breakers. One breaker for short power, other breaker for inverter, and other breaker for generator. This is the inverter, this is the generator, and this is the short power. Okay, this is the input from the short power, hot, hot, and neutral in the middle. This is the input from the inverter, hot, hot, and neutral. And this is the input from the generator, hot, hot, and neutral. Okay, let me check. The output is exactly the same, hot, hot, and neutral, hot, hot, and neutral. But I am going to connect together the hot of the first one with the hot of the second one with the hot of the third one. And from this connection, the black one, this is the output hotline to the AC panel. I am going to do the same with the neutral. This connected with this and connected with this, and from this is the neutral going into the AC panel. And with the phase number 2, it's exactly the same. This one connected with this one, connected with this one, and this is the output for the AC panel. In that way, if I turn on this breaker and this off and off, I am going to use only the short power, the power from the pedestal, and no power from the inverter and no power from the generator. Oh, I don't want, right now I want to use the inverter, off, off, and this one on. Or I want to use the generator, off, off, and this one on. This is the procedure to use three individual breakers instead of the switch selector. Some captains prefer the breakers separated. It's less expensive. It's easy to do the troubleshoot in comparison with the wiring on the switch selector. Right now, I am going to explain to you the procedure to do the wiring on the AC panel. Once again, we have the main AC panel, main breaker, individual breakers. We have the inverter. The input of the inverter is DC power, and this is the output of the inverter, AC power. And we have the short power connection. This is the outlet, this is the short power card, this is the power coming in. And this is the power coming from the generator. The generator is not connected in this moment. We have a generator, we have inverter, we have short power or short power inverter generator, depending if you use switch selector or if you use individual breakers. And additionally, we are going to connect the ammeter, the voltmeter, and the frequency hertz. Frequency, voltmeter, and ammeter. And in the breakers, in the individual breakers, we have one breaker for lights, other breaker for the battery charger, and we have another breaker for outlets. Those outlets, this is basically an example of the real situation. Okay, let me check. I show to yours in the back what happened. This is the situation in the back. This is the situation in the back. And now we are going to check the panel step by step. All right. This is the short power. The short power, hot, neutral, and ground. The ground goes directly to the ground bus bar, and the ground goes directly. This is the isolator transformer. Pass through the isolator transformer. Continue is interrupted, and you install the galvanic isolator. The ground continue into the bonding system, and from the bonding system finish into the sink. Let me repeat the path of the ground. The ground in this particular case is here. That's the ground bus bar. The ground bus bar goes directly pass through the transformer and is interrupted in order to insert the galvanic isolator and continue over there. When you insert the galvanic isolator, remember that episode, the episode related with the galvanic isolator, the capacity of the galvanic isolator in amps should be exactly the same capacity of the main breaker on the AC panel. This is the main breaker, excuse me, this is the AC panel, this is the main breaker, and those are the individual breakers. Okay, the main breaker, the capacity of this breaker, in this particular case, is 30 amps, and the capacity of the galvanic isolator is 30 amps. This one should be equal to this, and also the capacity of this and this should be equal to the capacity of the output breaker of the generator. 30 amps, 30 amps, 30 amps. It's exactly the same for all of them. Okay, this is the ground. Now, hot and neutral enter in the breaker for short power. Hot and neutral, this is the input. And this is the output from the inverter. Hot and neutral, and this is the breaker for inverter. And this is the power coming from the generator, hot and neutral, and this is the output, hot and neutral. And right now, I am going to connect the neutral of this connected with this, and the neutral of this connected with this. All of the neutrals are connected together, and from one of those connections, this is the neutral going, passing to the isolator transformer, continuing, and entering into the panel. The neutral bus bar and main breaker. After the main breaker, the hot line enter in the hot bus bar, and this is the output of the breaker. This is the output for lights, this is the output for outlet, and this is the output for battery charger. Once again, I am going to repeat. For example, in this moment, I am going to wire the power coming from the short power. Hot and neutral enter in the breaker for short power, and this is the output, hot and neutral. Okay, the power coming from the inverter, hot and neutral enter in the breaker for inverter, and this is the output. And the power coming from the generator, hot and neutral enter in the breaker designated for the generator, and this is the output. Okay, the outputs should be connected together. Neutral of the generator connected with the neutral of the inverter and connected with the neutral of the short power. And from that connection is the neutral of the output. Okay, the hot line of the generator is connected with the hot line of the inverter and the hot line of the short power. And from that common point, this is the output power passing through the isolator transformer. And this is the output of the isolator transformer, hot, entering in the main breaker. This is the output of the main breaker entering into the hot bus bar. And those are the outputs of each individual breakers. That's clear? Alright. In each breaker, you have in front of the breaker, if you check in the other side of the panel, let me show to yours like this. In front of each breaker, you have one LED. When you activate the breaker, the LED should be on. The LED, for this particular case, for this particular example, is similar to this one. It's an LED, one leg for neutral and the other leg for hot. Okay. All the LEDs, they have the neutrals, the yellow ones, connected to the neutral bus bar. And the hot is connected in the output of the breaker. When the breaker is activated, immediately the LED is on. Because the light, one leg is on the neutral bus bar, and the other leg is connected here in the output of the breaker. This is the breaker for the light. Now we are going to turn it, the board, and we are going to check the connection. The LEDs should be connected in the output of the breakers, not in the hot line at the input. Because if you connect here, the LEDs are on all the time. That's not good. Okay, this is the procedure to connect the procedure to do the wiring on the breakers. Okay, now we are going to connect the voltmeter and the ammeter. All right, this is the ammeter, this is the voltmeter, and this is the frequency. Okay, the ammeter. This is the donut. This is the hot line. You remember the hot line coming from the output of the transformer. Enter here, pass and enter in the main breaker. And the donut is here. The cables in the output of the donut enter in each terminal of the ammeter. Simple. The voltmeter. The voltmeter. One hot line is connected here with the hot line bus bar. And the neutral is connected to the neutral bus bar. And the frequency is connected neutral with neutral and hot with hot. That's too simple. Connect voltmeter, frequency, and ammeter. The ammeter should be with donut, and the donut should be connected through the hot line cable. How can I verify if the ammeter is working properly? I can verify that one with my clamp. With the clamp. The clamp is used to read amps in AC power. I recommend the clamps for AC. Okay, where you connect the donut? Okay, I want to know the consumption of all the system. Okay, I am going to read on the hot line at the input of the panel. And now I read how many amps are in the consumption. No, I want to check the consumption only of the battery charger. When the battery charger is, I turn on the breaker of the battery charger and I check here on the hot line of the battery charger. It's only on the hot line to read amps in AC power. With the voltmeter, I can check the voltage. I can check the voltage in any part of the system. I only select voltage and I check the voltage in between the neutral. I put one terminal in the neutral bus bar and I check in the output of each breaker or in the hot line or at the input. That's the procedure to use the voltmeter. Voltmeter and the clamp. Once again, the connection of the isolator transformer. The isolator transformer is connected in series with the main power coming out from the breakers or the switch selector. This is the switch selector and those are the individual breakers. The power enter in the isolator transformer, the power continue into the main breaker. The ground goes directly separated, pass through the case of the transformer, continue, is interrupted to introduce the galvanic isolator, and the ground continue, enter into the bonding system. This is the bonding system, and from the bonding system you have the sink, and the sink connected with the water. This is the typical wiring of the AC panel, and this is the procedure to do a troubleshoot to verify if one breaker is working or not. You use the voltmeter. To verify the consumption in amps, you use the clamp. Let me show to you right now. Alright, this is in this moment is connected the short power. I am going to select short power, inverter off, generator off. I have short power. I have power on the short power light. The LED is on, and right now I am going to connect the lights. Okay, the lights are on, or the battery charger. The battery charger start, the lights start, and the outlets. Those are the outlets. This is my boat. the light is on because it's receiving power. What is the meaning of that? The green light is on is because my polarity is properly. My polarity is properly. What happens if the reverse polarity will be on? If the red light for reverse polarity is solid, is on, it's because I switch the hot and the neutral on the panel. I connect on the neutral bus bar the hot, and the neutral is on the breakers. What happened in that case? If I have reverse polarity here, probably the light is on. This equipment is working, the outlets are working, but the neutral, let me explain that one. This is a critical situation. I'm going to turn off everything. Let me explain what happened if I have reverse polarity. If you have reverse polarity, it's because you connect this one, the neutral, on the hot bus bar, and you connect the hot on the neutral bus bar. You make a mistake and you connect the neutral on the hot and the hot on the neutral. Okay, what happens if you have reverse polarity? If you have reverse polarity, the neutral bus bar right now is hot. And the hot bus bar right now is neutral. Mr. Lopez, but I think that everything is okay because the light is on. The computer is on. Everything is on. Yes, my friend, everything is on, but right now the neutral bus bar is hot. What happens if for some reasons, look at this. This is the neutral bus bar and the other one is the ground bus bar. What happens if for some reasons you put one equipment, you connect the neutral with the ground or the ground with the neutral? Because there are technicians, there are electricians dedicated to work in residential electricity or industrial electricity, and they say that the neutral and ground can be connected together. This is not possible in marine application. Remember, in marine applications, only at the source of the power, neutral should be connected with ground. After that, should be separated. Separated bus bar for neutral and separated bus bars for hot. Never put together. If somebody enter in the boat and work installing other equipment and connect together this with this, and this one right now is hot, it's catastrophic. If this one right now is hot, and you connect suddenly the neutral with the ground right now, the bonding is hot, 120. Remember, what equipments are connected to the bonding system, to the bonding bus bar? You remember? The through holes, the metallic fuel tanks, all the metals inside of the boat shall be connected to the bonding metal. If the bonding metal right now is hot, the corrosion in the fittings, the corrosion on the through holes, the corrosion on the transducer is accelerated. And the boat suddenly is sink because those elements are perforated because the corrosion is accelerated. This is critical. If you have reverse polarity in a boat, immediately the bonding have power. The bonding have AC power. What is the enemy of the bonding system? Okay, the enemy of the bonding system is the current, the extra current. If the extra current is AC, it's more catastrophic because accelerate the corrosion in between two dissimilar metals together faster. What happens when you have two dissimilar metals together in a marine environment? You have galvanic corrosion. What happens if additionally when you have two different metals together, you have extra current passing through the metals? The corrosion is accelerated, especially if in between both of them you have humidity. The corrosion is accelerated and the more noble metal attack the less noble metal and destroy the less noble metal. This is catastrophic. For that reason, if you have the light of reverse polarity of the reverse polarity indicator on, you need to solve the problem immediately. If not, probably your bonding bus bar right now is powered with AC power with 120 or 240. Be careful with that. This is the procedure to do the wiring in AC power. I think that is simple. You need to be careful, use the appropriate tools, and use goggles. Be careful with the AC current. the AC current is critical. It's easy work with DC current. When you work with AC current, you need to be careful. Be careful with the reverse polarity, because normally on the neutral and on the ground bus bar you don't have current. But if you have reverse polarity, it's possible. You have reverse polarity because somebody switched the hot and the neutral, or because the short power line, the hot and the neutral is switched. This is other possibility. Now, okay, I hope you enjoy this video the same that I enjoy preparing the class for you. Don't forget the procedure to use the clamp, always on the hot line, and the procedure to use the voltmeter in between hot and neutral, or in between hot and hot when you are reading the voltage in between two phases.